Well, hey there, and welcome to 13.2, Identifying Proportional Relationships. All right, so remember as you go, make sure you are pausing, writing all of this information down. We're going to have some graphs here that you're going to need to copy, kind of sketch. Make sure you have all of that in your notes so that on the test you are good to go. Our objective for today is that students will identify if given equations, the tables, or the graphs represent a proportional relationship. All right, so you're going to give an equation. Is the equation a proportional relationship? You're going to give it a table. Is it a proportional relationship? And then also with a graph. All right, we have some big ideas today that I would like you to write down. So pause this, write this information down so you have that. So what is a proportional relationship? All right, well, here are some qualities, some characteristics of one. The first one is a proportional relationship can be written as a direct variation equation. So we've seen this back in Module 4 when we talked about a little bit about functions and solving this. We have this equation, excuse me, y equals k times x. So we will be using this equation, make sure you are writing the sentence down with this, as we solve here. The second item, is it a proportional relationship if the graph is linear? Okay, so if it is a line. If it has a constant rate of change, so every time there we're multiplying by 2, times 2, times 2, times 2, all right? The graph contains the point 0, 0. So if it goes through the middle of the graph, or in the origin, right, 0, 0, we know that is a proportional relationship. And also, if the constant of the proportionality, which is k that we find, is also the slope. So the slope is the same thing that we're doing every single time, and we'll talk about that in a second. Also note, a proportional relationship can also be called a direct variation. So you might hear that a little bit. Is this a direct variation? It's also a proportional relationship. Are these proportional to one another? Okay. If you don't have all these down, make sure you pause, write them down, and then we can head on to the next item here. All right, so when we look at graphs, when you are given a graph and asked if it is a proportional relationship, there are two questions you have to ask yourself. If both of them are yes, then it is a proportional relationship. If either of them, so if you get a no to either of them, it is not proportional. So here are the two questions. Number one, is it linear? So is the graph a straight line? Two, does it go through 0, 0? Does it go through the origin there? Okay. If those are both yes, then we know it's a proportional relationship. If not, they are not proportional. Okay, so go ahead and make sure you have this information written down. All right, so here's an example of a graph. Go ahead and sketch this graph. Go ahead and take a look at a couple points that you need to put there. Obviously, it's through 0, 0. And another point would be 3, 5. Over on the left side, be -3, -5. Okay, so just sketch that in there so you have that information. And like I said, those 3 points would be perfect. 0, 0, 3, 5, and -3, 5. Once you have this, then the question says, identify if the graph represents a proportional relationship. If not, you need to explain why. All right, so remember our two questions here. Is it linear? All right, well, if I look at my line here, that looks like a straight line, you bet. So that would be a yes. Does it go through the point 0, 0? So here's 0, 0. Yes, it does. So this would be a proportional relationship. Okay, so if it's a yes, I don't have to go any further. I'm done. All right, let's try the next one. Identify the graph represents a proportional relationship. If not, we got to explain why, right? So go ahead and make a graph again. I know you may have to pause a lot here on 13.2. We have a couple order pairs you can put on so that you make sure you kind of have the sketch. So at 3, 0 and 0, -3. So if you just put those 2 points and then connect them, you have this line here. All right, so number one, is it linear? Yeah, that's a straight line, right? We're not going up and down all over, or it's curved. Number two, does it go through the point 0, 0? Oh, this one does not. So this is not a proportional relationship. Okay, so I would write no, and remember if it's no, you have to explain why. So I would just say it does not go through the point 0, 0. So if it's not linear, if it's not a straight line, you could say no, it's not a line, it's not linear, and it doesn't go through the point 0, 0. All right, so those are looking at graphs. So those two things have to be true in order to be a proportional relationship. All right, what if we have equations now? Is an equation a proportional relationship? All right, it is if it can be written in this form right here. Y equals k times x, right? And k is our constant. What is happening each time here? So now we're going to get a couple equations, and we have to identify, is it a proportional relationship? Okay, so write down this information. All right, so identify if each equation is a proportional relationship. If it is, write the equation in the form y equals kx. If not, explain why. All right, so let's start with this first one here. I want it in y equals kx. So the k here has to be the number. So number x. We're close here. I want y by itself, so this is multiplying, so we're going to divide both sides by 5. All right, y equals 2x. That is in this equation form. So k represents the number 2. So this k in this form here will be a number. So the first one is a proportional relationship because I can rewrite it by solving for y into y equals 2x. That's this form. This is y equals kx. K is going to be the number, and then you keep the y and the x. Let's look at the second one. Y equals x squared. All right. Sorry. Y equals x squared is not a proportional relationship. Anytime you have this x, the square root with here, your graph makes a U shape, and that is not a line, right? So proportional relationships, we know part of the graph has to be a line. Well, that is not a line, right? So y equals x squared is not a proportional relationship, so no, it is that because I can't write it in that form. To explain this, we can say it does not fit the form, or we can say that x squared it does not make a line, right? All right, so let's look at the next one. Y equals x plus 4. Now we're kind of in this form. We're really close. The k here is 1, but we're adding 4 to the end here. When we add 4 to the end, I have nothing over here, and I don't want anything over there. So y equals x plus 4, it is a line, but however, if I put a number in, this will not go through the origin. So this is not a proportional relationship. So anytime I'm adding or subtracting at the end here, when I have y equals x, if there's a plus or a minus here, that is not a proportional relationship. Alright, so again, this is a line. It just will not go through the midpoint. Alright, 12y equals 24x. We can go ahead and solve this. It looks like we have y over here, but I just want regular y, not 12y. Alright, so there we go. We have our y equals 2x. That is in that form, so we're good to go. And the last one here, y squared equals 14 is not proportional because, just like our x squared, we have y squared here, and there's no x over here. So, no, that is not proportional. Okay. So that's not a line. It does not fit our form. All right, let's go to the next item here. What about a table? All right, does a table represent a proportional relationship? There's two options to do. Number one, we could set up a proportion for each set of values there. So we're going to look at that here in a second. Will that work out? And then option two is identify the ratio and then see if it's the same for each one, right? If your proportions or ratios are the same all the way through the table, then you can say it's proportional. If any of the ratios are different, it is not proportional. So if you're getting them to be the same, you have to keep working. Whenever you get a no, then you can stop and say it's not proportional. Okay, so make sure you have these options written down here. All right, identify each table as proportional relationship. Make sure you show your work. We have two options. I'm going to solve one of these tables one way and the other way. So kind of follow along with me as we go and make sure you write this down. You can decide which way you like best, though, on your paper, on your homework tonight, and you decide which one it works for you. Okay? All right, so go ahead and copy down this table. So again, a lot of pausing. And the first way, I'm going to work with option 1. I'm going to go back for a second. So I'm going to use option 1. I'm going to set up a proportion for each of them. All right, so when we set up a proportion, we always do y over x. So I'm going to put the y on top over the x on the bottom. All right, so I do y over x. I'm going to take the first values here, so -6 over -4 equals -3 over -2. So y's over x's, and now I'm going to cross multiply. If I get the same answer, then yes, it is proportional. If I get a no, then it is not proportional. All right, so 4 times 3 is 12. Negative times a negative is a positive. So 12 equals 12. It worked both ways there. So far it's proportional. Now I'm going to go to the next number. I'm going to add in 0, 0. All right, so I added a different color so you can kind of see what I'm doing. I took -3 over -2 now, and I set it equal to 0 over 0. -3 times 0, 0. -2 times 0, 0. Now I'm going to keep going. Because I kept getting them equal to each other, you have to keep going. You have to look at all of them. So because these matched 12 equals 12, 0 equals 0, these were all true statements, then I can stop, right? They are all proportional to one another. So yes, this is proportional. All right. The second one now, I'm going to do the other way. So the other way is just to figure out, divide your first fraction out. So I would divide this out, find my answer. If I all get to be the same, then yes, they're proportional. When I get the first time that they're different, I can actually stop. I don't have to do the rest of them because I know it is not proportional. So again, we're going to do y over x, and then we're going to divide it out. All right, so then in your calculator, I would take -5 divided by -2, and I would get 2.5. All right, on the next one then, I took -4 divided by -1, and I got a +4. Ooh, but look. When I divided the first one out, I got 2.5. When I divided the second one out, I got 4. Because these are not the same answers, I am going to have to say no. Okay? I would say no. So when I cross multiplied, when I looked at 2, I got to have the same number. 2, same number. Here, once I get a different number, then I say no. That is not a proportional relationship. All right, your assignment is 13.2 worksheet. Make sure you are drawing the graphs, you're drawing the tables, right, all of that. You are showing proportional relationships.